The flash point of a volatile material is the lowest temperature at which it can vaporize to form an ignitable mixture in air. Measuring a flash point requires an ignition source. At the flash point, the vapor may cease to burn when the source of ignition is removed. The flash point is not to be confused with the autoignition temperature, which does not require an ignition source, or the fire point, the temperature at which the vapor continues to burn after being ignited. Neither the flash point nor the fire point is dependent on the temperature of the ignition source, which is much higher. The flash point is often used as a descriptive characteristic of liquid fuel, and it is also used to help characterize the fire hazards of liquids. A OE flash point refers to both flammable liquids and combustible liquids. There are various standards for defining each term. Liquids with a flash point less than 60.5 or 37.8 AA degrees Celsius depending upon the standard being applied are considered flammable, while liquids with a flash point above those temperatures are considered combustible. Mechanism: every liquid has a vapor pressure, which is a function of that liquid's temperature. As the temperature increases, the vapor pressure increases. As the vapor pressure increases, the concentration of vapor of the flammable liquid in the air increases. Hence, temperature determines the concentration of vapor of the flammable liquid in the air. A certain concentration of vapor in the air is necessary to sustain combustion, and that concentration is different for each flammable liquid. The flash point of a flammable liquid is the lowest temperature at which there will be enough flammable vapor to ignite when an ignition source is applied. Measurement. There are two basic types of flash point measurement, open cup and closed cup. In open cup devices the sample is contained in an open cup which is heated, and at intervals a flame is brought over the surface. The measured flash point will actually vary with the height of the flame above the liquid surface, and at sufficient height the measured flash point temperature will coincide with the fire point. The best known example is the Cleveland open cup. There are two types of closed cup testers: non-equilibrium, such as Penske Martins where the vapors above the liquid are not in temperature equilibrium with the liquid, and equilibrium, such as small scale where the vapors are deemed to be in temperature equilibrium with the liquid. In both these types the cups are sealed with a lid through which the ignition source can be introduced. Closed cup testers normally give lower values for the flash point than open cup and are a better approximation to the temperature at which the vapor pressure reaches the lower flammable limit. The flash point is an empirical measurement rather than a fundamental physical parameter. The measured value will vary with equipment and test protocol variations, including temperature ramp rate, time allowed for the sample to equilibrate, sample volume and whether the sample is stirred. Methods for determining the flash point of a liquid are specified in many standards. For example, testing by the Penske Martins closed cup method is detailed in ASTM D93, IP34, ISO 2719, DIN 51758, JISK 2265 and AFN ORM 07-019. Determination of flash point by the small-scale closed cup method is detailed in ASTM D3828 and D3278, ENISO 3679 and 3680, and IP 523 and 524. CENTR 15138 Guide to Flash Point Testing and ISO Trail 29662 Guidance for Flash Point Testing cover the key aspects of flash point testing. Examples: gasoline is a fuel for use in a spark ignition engine. The fuel is mixed with air within its flammable limits and heated above its flash point, then ignited by the spark plug. To ignite, the fuel must have a low flash point, but in order to avoid pre-ignition caused by residual heat in a hot combustion chamber, the fuel must have a high autoignition temperature. Diesel fuel flash points vary between a 52 and 96 AA degrees Celsius. Diesel is suitable for use in a compression ignition engine. Air is compressed until it has been heated above the autoignition temperature of the fuel, which is then injected as a high-pressure spray, keeping the fuel air mix within flammable limits. In a diesel-fueled engine, there is no ignition source. Consequently, diesel fuel must have a high flash point and a low autoignition temperature. Jet fuel flash points also vary with the composition of the fuel. Both Jet A and Jet A1 have flash points between 38 and 66 AA degrees Celsius, close to that of off-the-shelf kerosene. Yet both Jet B and JP4 have flash points between a 23 and a 1 AA degrees Celsius. Standardization. Flash points of substances are measured according to standard test methods. These test methods define the apparatus required to carry out the measurement, key test parameters, the procedure for the operator or automated apparatus to follow, and the precision of the test method. Standard test methods are written and controlled by a number of national and international committees and organizations. The three main bodies are the CEN/ISO Joint Working Group on Flashpoint, ASTM D2.8B Flammability Section, and the Energy Institute's TMSSCB4 Flammability Panel. See also, autoignition temperature, fire point, material safety data sheet, Petro test, references.